Hello everyone. So last time we were discussing section 19 in the class. So now we have shifted to online classes. So welcome to online learning. Today I'm gonna just review some of the formulas that we did in section 19. So please pull out your handout of section 19 while you watch this video so that you can work along with me. So we discussed some formulas for the derivatives of trigonometric functions. So I have the summary of all the formulas here. Similarly, we also discussed the derivatives of inverse trigonometric functions. So we learned that derivative of arc sine is given by this formula. If you want, you can also write this as sine inverse x. So whatever form you prefer. So you can use that for. Take a moment to read the problem and understand it. So what we are given in this problem is, so there is a blue room which is in the middle of two towers. So on one side it has IMG tower and other side it has HSBD tower. So they have given us that IMG tower is 30 meters above the roof of blue room. Similarly, the other tower is 15 meters above the roof of blue room, and they want to install a skylight on the roof, and they want to ensure that they have the maximum viewing angle. So it is given that the blue room's roof extends 20 meters in total. So this is 20 meter. And also, let's say x is the distance of the skylight from one of the towers. So I'm just going to redraw the diagram and so that we can make sense of the problem. So we have two towers and this is the blue room's roof, and then one tower is 15 meters above the roof and another tower is 30 meters above the roof. And we are given that the total length that blue room's roof extend is 20 meters. So let's say we put the skylight x meters away from our IMG tower. So if we do that, so it means the distance that it is away from the other tower would be 20 minus x. And we want to maximize the viewing angle, so it means we want to maximize. So let's join these lines together, the top of the towers with where we put the skylight. So this angle is theta. So the problem is we want to figure out the distance x, which helps us in maximizing this viewing angle theta. So what we want to do, we want to maximize angle theta by varying the distance x. So basically this is an optimization problem. So whenever we have an optimization problem, the first thing we do is we figure out the function in terms of the variable. So first step is find the function theta in terms of x. And then in order to maximize or minimize, you will do the same things that we have done before. We will take the first derivative and then we will set the derivative equal to 0, and also we will check at the endpoints, and then we will figure out whether it's a maxima or minima. So in this question, what we can do, so in order to figure out our theta in terms of x, I'm going to split our angle in terms of two angles. So let's say I'm just going to make a vertical line in the center here. So on one side, I have angle theta 1, another side, I have angle theta 2. So it means our theta would be equals to theta 1 plus theta 2. So the advantage of splitting the angle is that we can use the trig ratios here. So in this scenario, so we know that if this angle is theta 1, so this angle will also be theta 1 because we have alternate angles, and similarly the same thing applies to the other angle theta 2. So if this is a vertical line and we have a vertical line here, so this angle should be same as angle theta 2. So these are the alternate interior angles. So now if we look into the first triangle, so let's take a look here. So in this triangle, so if I try to write my trig ratio, so I know that this is 90 degree, this angle is theta 1, so it means this is our adjacent side, this will be our opposite side, and this will be our hypotenuse. So using the tangent trig ratio, we can say that, so from here we get x over, and again we notice that this is our adjacent for angle theta 2, this will be our opposite, and this will be our hypotenuse. And again, so tangent theta 2 would be, right, so from here we got theta 1 is equal to tangent inverse x over 30. Similarly, we got theta 2 is equal to tangent inverse 20 minus x over 15. So clearly we got theta 1 and theta 2 as a function of x. So we can write our function of theta x tangent inverse x over 30 plus tangent inverse 20 minus x over 15. So I just simply put the values in this equation. So this is our main function which we wanna maximize now. So this is our main function. And we want to maximize this. And we want to figure out for what values of x this has the maximum value. So we're going to take our first derivative now. So d theta over dx. So we need to find d theta over dx for that and set it equal to 0. So from here we will get d theta over dx, and if you remember last time we did the trigonometric formula for tangent inverse x was 1 over 1 plus x squared. So we're going to use that formula, but since here we have tangent inverse x over 30, so let's just take the derivative of tangent inverse x over 30. Similarly, we're going to take derivative of tangent inverse 20 minus x over 15. Alright, so now we notice that here we have x, but here we have x over 30. And we know that whenever we have another function in between, so we have an outside function and inside function, we always apply chain rule. So the key thing is don't forget to apply chain rule. So let's take the derivative. So d theta over dx would be, so first we apply, so tangent inverse. So derivative of tangent inverse is 1 over 1 plus whatever the angle square. So angle here is x over 30, square of that. But by chain rule, we also need to take the derivative of x over 30. Similarly, for the other part, again, using the formula, so tangent, so again we have a different variable inside the bracket, so angle is different, it's not x, so we're going to use this whole expression in place of x. So it would be 1 over 1 plus angle square, and since this angle is not x, it's something else, we need to take the derivative of inside function. So from here we got 1 over 1 plus x square over 30 square, 1 over 30. Similarly, 1 over 1 plus 20 minus x square over 15 square times negative 1 over 15. Alright, so moving on, we can do some algebraic simplification. So here we got, down we have 30 square plus x square over 30 square. We can take that to the top, and 1 over 30. Similarly, we have 15 square plus 20 minus x square minus 1 over 15. So here I simply took the common denominator, added the fractions on the bottom, and then did some algebraic manipulation. So here we can see that 30 and 31 set of 30s cancel. Similarly, one set of 15 get cancelled, and we are left with 30 over 30 square plus x square minus 15 over 15 square plus 20 minus x square. So before we set this equal to 0, it's a good idea to add both the fractions together. And in order to add them together, we need a common denominator. So what we do here is, we take the common denominator. So denominator would be multiplication of both the denominators. And then you use the cross multiplication. So 3 times 15 square plus 20 minus x square. Similarly, negative 15 times 30 square plus x square. So the bottom expression looks really big. So I'm just going to name this as an A so that I don't have to write that over and over. So, or maybe D. So this is my denominator D. So in the next step, I can do some more simplification of the numerator. So in the numerator, I can take 15 out. Inside, I'm left with 2 times 15 square plus 20 minus x squared, so minus 30 squared plus x squared, and the whole thing is divided by d, where d is equal to 30 squared plus x squared times 15 squared plus 20 minus x squared. So we got 15 over d, and inside we have 2 times 225, and then you can open a minus b whole square, which means a square plus b square minus 2ab. And the last one is we have negative 900 negative x squared. So again, let's just combine the like terms. In order to combine the like terms, so we have 625, so we get 1250 plus 2x squared minus 80x minus 900 minus x squared. So just so that you know, so this was 625 and times 2, that gives us 1250. So if we combine them together again, so combining the like terms, we got 1250 minus 900 gives us 350 minus 80x, and plus 2x squared minus x squared gives us plus x squared. So now, so this is our d theta over dx, and the denominator d is this whole expression. So now we want to set this equal to 0, so it means d theta over dx equal to 0 implies that the numerator should be 0. So it means 350 minus 80x plus x squared should be 0. So you have a quadratic equation, and you can use your calculator to figure out the roots. So if you use the calculator, so you will see that we get two values of x. So x is equal to 75.4 meters, or x is equal to 4.64 meters. Since we know that x cannot exceed 20, so this is not possible in this problem. So it cannot exceed 20 because the total length of the roof was 20. So x has to be less than 20. So it means we will go with this value of x. So let's see what we get at the endpoint. So if you use, so just to remind you, so our function was theta x is equal to tangent inverse x over 30 plus tangent inverse 20 minus x over 15. So in order to see whether this is a point of maxima, the x is equal to 4.64 gives us a maxima or minima. So what we can do, we can figure out the value of angle theta when x is 4.64. So theta x is 4.64 gives us, so when you put the values in, tangent inverse 4.64 over 30 plus tangent inverse 20 minus 4.64 over 15. So you will see that you get theta approximately equals to 54.5 degrees. Similarly, we're going to check at the endpoints. So at end points, because we know that the range for x is 0 to 20. So minimum it can be 0, maximum it can be 20. So it means we will plug in x equals to, let's plug in x equals to 0 and then we get angle approximately 53.1 degrees. If you plug in x equals to 20, so you will see that you get angle approximately 33.7 degrees. So out of all these values, the maximum viewing angle is this one. So thus we get the maximum viewing angle is roughly 54.5 degrees, and we get it by placing our skylight, the skylight 4.64 meters away from the IMG tower. So this was our optimization problem. So we followed the exact same steps. You figure out the function theta that you want to maximize. You figure out the first derivative, and then you just set the derivative equal to 0, and it will give you the answer. So make sure you revise section 18 and section 19 for your quiz next week, and I will start with a new section in next video. So happy studying!